Hello and good morning, good afternoon, or good evening to whenever you may be watching this video. But this is our red wine quality project video. In this project, we explored the relationship between different chemical properties of red wine and its quality rating. We used Python and JupyterLab for our analysis, combining statistical testing and visualizations to draw conclusions. This notebook is structured with and markdown explanations and common code cells to guide the viewer through our process. My name is Shalom Emmanuel David, and I am joined by my project mates Yair Hernandez and Juan Garza. We work collaboratively by meeting regularly and checking in on each other's progress. Each person contributed equally to discussion and final review. We also refer to AI for collaborative help whenever we were stuck to complete our code. And our research paper references is taken from modeling wine preferences by data mining from psychochemical properties, and the dataset we used to complete the project was the red wine quality dataset from the Kaggle website as given by our professor. We started off by performing exploratory data analysis, looking at the data frame and printing out data summaries using .head, .info, and .df describe to understand the structure, data types, and any missing values in the data set as we were instructed to. And as you can see here, this is the information that was printed out for us using the exploratory data analysis coding. And here is what we have for the info, and here's what we have for the description of the data set. All the information aligns directly with the red wine quality CSV from the variables that are within the document to all the amount values that are given. We were also instructed to look for any missing values within the data set, so we ran the code for that. So we loaded the data set, we checked for any missing values, and to our pleasure and our surprise, we found that there's no missing information within the data set, as you can see by all the zeros here. We now move to the graph analysis as the second part of the exploratory data analysis. I was responsible for creating the visualizations that helped us better understand the dataset. I started by generating histograms for all the numerical columns to get a sense of how each variable is distributed. And here is what right out here. We used a red overall theme for all of our graphs, so it is easy on the eyes and easy to see. I also generated box plots, as you can see here, and I also created a heat map. We took inspiration and some help from the previous projects that were already created on the Kaggle website to help our own project. I also created a pair plot for selected graphs, and I chose all of these qualities from the 11 as you can see here. I now pass it over to Yair for his part on describing and explaining the classification model.
Hello, so for my part, I built a basic perceptron model to classify whether a wine is good or bad based on some key features. After training it on sample data, I created an interactive tool that asks the user a series of yes or no questions like whether the alcohol content is between 9 and 14 or if the pH is in certain range. The responses are converted into a numerical format that the model can understand, and based on that input, it makes a prediction. If the wine is classified as good, the system gives a positive message. If not, it gives a suggestion to explore other options. While the model is simple, it is a good way to apply machine learning in a more interactive and approachable way. For this part of the code, it's just defining the perceptron class. As you can see, I converted the y to be -1 and 1 for the perceptron algorithm. On this part of the code, it's just it prepares the interactive classification So it asks the user yes or no questions, and then for this part, it's just it classifies the wine as good or bad based on the answer of the questions provided previously. These are some of the questions that we chose, that I chose. One of them is the pH level between 3.2 to 3.6. Another is the alcohol content between 9 to 14. And then another one is the total sulfur dioxide between 20 and 80. And this part of the code is just mapping the yes and no responses to a numerical feature vector. And then for this part of the code, it provides the response based on the classification. So if the questions asked previously, and this classifies if it's good. If it's good, it will give you this line of response right here. And if it's bad, if it's classified as a bad wine, it will give you this line right here. So as you can see, if we run this code right here, if you see we run this code right here, I'll put yes, for example, put no, yes, yes. Then as you can see, the wine is classified as bad, and then the response that it gives you is this line right here. Also, the classification of what makes the wine good or bad is influenced by heavier factors such as the alcohol and total sulfur dioxide, which are the two most important variables when deciphering if a wine is bad or good. Now for the next part, I'll pass it on to Juan so that he can explain.
Okay, so here I made a bar chart to show how many wines are rated from 3 to 8, as you can see here in quality. First, I filtered out the data set to only include those scores, which you can see right here. Then I grouped them to count how many wines each rating had each rating. The chart shows that most wines in our data set were around 5 or 6, and the fewer wines at the extremes, like 3 and 8. I used red bars with black edges to match the wine theme and added labels, a title, and grid lines to keep it clean and easy to understand. This gave us a quick, easy visual summary of the quality distribution before we moved on to deeper analysis. And here's the code as to give the graph details. And then for this part, I wrote a function to calculate every metrics like accuracy, precision, recall, and F1 completely from scratch, as you can see here. Without using any built-in libraries, I started by looping through the true and predicted values to calculate the true positives, true negatives, and false negatives. Then I used those counts to compute each metric using the standard formulas. This gave us a better understanding of how the model was actually performing and helped us spot any weakness in this prediction. It was a good way to practice working with raw output and also made sure we fully understood what each metric means in context. And here's the code that we did. In conclusion, to wrap things up, this project helped us build a much stronger understanding of how to work with real data, from cleaning and visualizing it to apply statistical tests and building a basic machine learning model. We learned how to evaluate model performances using metrics we calculated ourselves. And we also developed an interactive tool that made our project feel more hands-on. We worked together as a team and divided responsibilities and managed our time to make sure everything came out together. We also believe it is important to acknowledge that we use AI tools like ChatGPT throughout this project, not to complete the work for us, but to help us understand complex coding steps and explain unfamiliar concepts, especially since we were first-time coders. Overall, we're proud of what we were able to learn and accomplish, and we're leaving this project with a stronger, more realistic understanding of how data